So hopefully by now we have a pretty good understanding of our simple probability. You've been doing that over the past couple of years. So we're going to go a little more in depth into our compound probability. So first of all, a compound event, that means two or more simple events are occurring. And we have two types of compound events. We have independent and dependent. So we're going to deal with our independent first. Well, that's where one has no effect on the other one. Yeah. And that one's pretty straightforward, and I'm sure you've done this before. You usually see the word and when they're independent. And whenever you see the word and, we're thinking, man, this is going to end up being multiplication. So basically, you find the probability of the first event and the probability of the second event, and you multiply the two probabilities. And remember, probability could be written as a fraction, could be written as a percent, and I suppose you could write it as a decimal as well. You usually see one or the other. So let's take a look at an example. Well, let's think about something basic. What happens if I would, let's say I was going to roll a die and I was going to flip a coin. Those are two totally different things. Okay, and I wanted to see what's the probability of rolling a 2 and flipping a head. Well, probability of rolling 2 is 1 out of 6, because there's only 1 2 on a 6 face die. And a head, well, there's one side that's a head out of 2 total sides. And I'd multiply, so it's really 1/12. There's a 1 in 12 chance that I would roll a 2 followed by flipping a head. They would both have to occur with the word and. So there's kind of an independent situation with a compound event. Okay, it could also be with percents. For example, here it says Ray is flying from Birmingham to Chicago on a flight with a 90% on-time record. On the same day, the chances of rain in Denver are predicted to be 50%. What's the probability that Ray's flight will be on time and that it will rain in Denver? Well, if I think about this, these two situations have nothing to do with each other. So these are both independent events. That's where I know I can just take each probability. So probability of event 1, 90%. And probability of event 2, 50%. And we multiply them. But we don't use our percents. We always change to a decimal and multiply. So 2 to the left, so 0.9 times 0.5, which gives us 0.45, which is how many percentages? Well, 45% chance that it'll be on flight as well as it raining in Denver. That both would occur. Okay, that should make sense, because if it's a 50% chance to rain in Denver, and it's almost 100%, but not quite that my flight's on time, it should just be a little bit below 50, which we got at 45%. Okay, let's take a look at this next one. How about this? A bag contains 6 black marbles, 9 blue, 4 yellow, 2 green. A marble is selected, replaced, that's a key word, replaced. That's what makes them independent events. The fact that it's replaced back in there. And then a second marble is selected. Find the probability of selecting a black marble, then a yellow. So for the black, we got 6. There's 6 possible that I could pick out of a total of, well, I got to add these together. So 6 plus 9 plus 4 plus 2, which gives me a total of 21, it looks like. So 6 out of 21 for the black. I'll put B up here for black. And then for the yellow, I'm going to use the red color. So for the yellow, it's what? Well, I replaced it. So there's 4 yellow to pick from out of a total of 21. Okay, it would be 20 if I didn't replace it, but then they wouldn't be independent anymore. And we're going to multiply. I could simplify first if I wanted to. For example, like 6 over 21, 3 goes into both. 3 goes into there twice. 3 goes into there 7 times. Might make it a little bit, I don't have to simplify at the end. So 2 times 4 is 8, and 7 times 21 is 147. And I'm guessing that is my simplified form. And I could double check here on my calculator. And there we go, 8 over 147. So 8 and 147. And if it wanted me to write it as a percent, I could just divide 8 divided by 147 and move my decimal place twice to the right. So I could say it's about a 5.4% chance as well. Either way, probably the fraction if they don't specify. Okay, well, dependent, we just kind of talked about that. If I want to replace that marble, then they would have been dependent, because that second situation, would have been affected from that first one because I pulled out a marble and now it's not replaced. So basically it's the same thing. We're still dealing with and, so we still multiply, but it's going to affect what the second probability looks like. Let's take a look at one of those. So Cynthia randomly draws 3 cards from a standard deck, one at a time, without replacement, given the probability that the cards are drawn in the given order. So it's saying find the probability that we draw a 2, and then a 5, and then not a 5. So I have to take each one separately. So the probability of drawing a 2. Well, how many 2s are in a deck? 4 out of 52 total cards. Okay, now let's go for the 5. All right, 5. How many 5s are in the deck? Well, there's still 4 5s in the deck, but there's no replacement. So how many cards are left in the deck? 51. There's only 51 cards left in the deck now. And what about for not a 5? Well, we got to think about this here. How many 5s are in the deck? Well, we just said that we're pulling out a 5, and we've already pulled out a 2, so there's really only 3 5s left in the deck. And how many total cards are left in the deck? Well, there's only 50 left in the deck, so how many of those are not 5s? 47, right? 50 minus 3 is 47. So you got to think through that one a little bit, okay? Some of you might be a little confused there. That's okay. Just you got to really think through. So the 2, right? All 52 cards were still there. For the 5, probability of 5, only 51 were left. And then for the not a 5, only 50 were left. But we already pulled out a 5, so there are only 3 5s. So that means 47 and not 46 out of 50. Kind of confusing. Hopefully you get a good understanding of that. And then we multiply. So if you got a calculator, you can write them all as fractions. I can go 4 over 52 times 4 over 51 times 47 over 50. And we end up with, that gives me a nasty decimal. Let's simplify here and we'll check it out. So 4 goes into itself once. 4 goes into 52 13 times. Can I simplify anything else? It doesn't look like it. Then I can multiply across. Well, 4 times 47 is 188. And 13 times 51 times 50, it's a big number, 33150. That's a big fraction. Well, let's go ahead and let's write this as a percent. That might look a little bit cleaner. So I'm going to divide those two, and I get about 0.0056. So that's about a what? In my decimal place, 2 to the right, about a 0.6% chance. Ooh, boy. But that should make sense. I mean, what's the probability that I pull out a 2? Not very good. And then a 5 after that, and then not a 5. Okay, my percent chance shouldn't be that great, so it should make sense. That's good. Okay, well, we have something called disjoint events. Okay, these are events that cannot happen at the same time. They're what should we say, mutually exclusive. So they can't happen at the same time. It's nice and easy. You usually see the word or for disjoint events, which means we're just going to add them up. Okay, the or you're thinking adding, except you got to be careful. It's easy when they don't occur at the same time. So for example, here's a couple of them, right? Probability of a 7 or an 8, right? I can't pull out a 7 and an 8 at the exact same time. So what's the probability of pulling out a 7? Well, 4 out of 52. What's the probability of pulling out an 8? Well, 4 out of 52. You just add them up. So it's really 8 out of 52, and we'd simplify that. And 4 goes into the 8 twice, and 4 goes into 52. Well, we just talked about that 13 times. So it's really 2 out of 13. And the same thing over here, neither club nor heart. Well, it couldn't be a club and a heart at the same time. So how many cards are neither a club or a heart? Well, then they have to be either what? A spade or a diamond. And that's basically half the deck, so 26 out of 52. And for a spade, it's 13 out of 52. And for a diamond, there's 13 out of 52 for 26 out of 52, which is really a half. Okay, so it's really, you just add them together. Well, what happens if they're not mutually exclusive? If they actually could occur at the same time? This is kind of our one confusing thing that we have to do. You'll see the word or, so you're thinking just adding. But if they can occur at the same time, what you do is you do it just like you normally would. You'd add them together, but then you also find it for your and situation. Our compound and situation. And then you subtract, you find the difference between those two probabilities. Okay, so really you're doing the or, just the regular addition. You do the and where you multiply them, and then you subtract the two. That's when they can occur at the same time. And you'll see that here in this example. So a card is drawn from a standard deck of playing cards. Find the probability situation. So probability of a spade or an ace. Well, there's a chance that that's an ugly card, but that's okay. There's a chance that I could pull out the ace of spades, right? There is a chance of that. So that would be both of them at the same time. So that means I'm going to have to do the probability of those two being added. So let's think about this. So let's find out what each one is. So the probability of a spade is what? 13 out of 52. And the probability of an ace would be 4 out of 52. Okay, so for the first part, remember we add them, we multiply them, and then we subtract those two probabilities that we find. So let's add them first of all. So 13 over 52 plus 4 out of 52. And we end up with 17 out of 52. And then we'll subtract. And over here it looks like we got 13 out of 52 again. Times 4 out of 52. And I could simplify. So go ahead and use my calculator on this one. 13 over 52 times 4 out of 52. And I get 1 over 52. And we subtract, and in the end, 17 over 52 minus 1 over 52 gives us 16 over 52. And let's go ahead and simplify that, which gives us 4/13. 4/13. Okay, so if they can occur at the same time, they're not mutually exclusive now, and we'd have to do each of them. You add them, and you multiply each probability, and then find the difference between those. Okay, so that's the only one you really, really have to think about. Okay. So if you got a little bit better understanding on our compound probabilities.